everyone, welcome to this next question on complex analysis. This question is related to bilinear or Mobius transformations. So first of all, you should know what is a bilinear transformation. This bilinear transformation, that is a special kind of mapping, a special kind of conformal mapping. What is conformal mapping? Conformal mapping is one which conserves the angle when you transform particular z plane to the corresponding w plane. So in bilinear transformation, we say the transformation w of z defined like this: az plus b divided by cz plus d. This is a bilinear transformation whenever the this factor ad minus bc is not equal to 0. So that is the characteristic for identifying the transformation to be bilinear transformation. So now in this case, they are saying we are given these two transformations. These are given to be bilinear transformations. So for the first wz, we have ad minus bc not equal to 0. And for f of z, which is defined to be alpha z plus beta divided by gamma z plus delta, here alpha into delta minus gamma into beta should not be equal to 0. So now in order to see which among these four is correct, so first of all, let us evaluate f of z into this omega of or w of z. So when you multiply these two transformations, so you would have something like this multiplied by the second transformation, right? So it would simply be, you have to multiply these two. So it would simply be a alpha z square plus a beta plus alpha b into z plus b into beta divided by c gamma z square plus c delta plus gamma d into z plus d delta. Now, do you know why the name bilinear is given to these kind of transformations? It is because these transformation, when you if you see this thing, when you multiply this term with this term, so you would have something like this: czw plus dw minus az minus b is equal to 0. Or you so here you see this equation is linear in z. How? You see, you can common z from these two terms. So you would have z to the power 1 into something plus the constant term. So it is linear in z. Another thing, it is also linear in w. How? If you can take w common from these two terms, and these are constant terms. So w to the power 1 into something plus something. So that is also linear in z as well as in w. So we say the transformations are bilinear, right? So coming back to our question, the question is to identify whether this is a bilinear transformation or not. So in this case also, you should have something of the sort az plus b divided by cz plus d, where this ad minus bc should not be equal to 0. So we need to check this condition in order to check whether the given transformation is bilinear or not. So here you cannot further simplify this thing, and you see we have z to the power 2 over here and z to the power 2 over here. So this is not a bilinear transformation. So let us go and check for the second case, where this is f of wz. So that means we have composite functions. So firstly we'll substitute this value of this transformation. What is w of z? It is given to be az plus b divided by cz plus d, right? And moreover, now we'll apply this particular factor into the definition for this term. So we would have something like alpha into az plus b divided by cz plus d, right, plus beta, and then divided by gamma into the same factor plus delta. So now we can simplify this term, right? So let us simplify this. So it would be alpha A Z plus alpha B plus you can multiply this thing, right? Beta C Z plus D beta, and then divided by A gamma Z plus gamma B plus delta C Z plus delta D. So now you can factor these out. So you can take the terms common. So you would be having So you see here we can take z common from this term alpha into A plus from this term beta into C, and then we have the constant term alpha into B plus D into beta as such, and then similarly in the denominator we have something like z into A gamma plus delta C, right? And then we would have gamma B plus delta D. So these are the constant terms. Now this transformation would be bilinear transformation. So if I write this transformation to be of this form A, Z into A bar plus B bar divided by, or we can write simply this to be Z into A plus B divided by Z into C plus D, then this A D minus BC should not be equal to 0. So in order to check this AD minus BC, we just have to check A is this term, right? So that would be alpha A plus beta C into D term. D is this one. So that would be gamma B plus delta D minus of B into C. So B is this term. So we would have alpha B plus D beta, and then we would have A gamma plus delta C. So now we can solve this thing. So you can solve this thing, you can multiply all the terms. So it would be, after simplifying this, you would get alpha delta minus beta gamma into AD minus BC. So you can simplify this. I assume you can do this. So now obviously this term is not equal to 0 and this term is not equal to 0. Why? Because the corresponding WZ and FZ, they were given to be the bilinear transformation. So this term is not equal to 0 and this term is also not equal to 0. So using these two expressions, our equation, this AD minus BC, that is also not equal to 0. So if this is not equal to 0, we can clearly say that the transformation of the composites F, W of Z, this is bilinear. So we got our answer. So option B over here is the correct option. Similarly, you can check for the C part and D part, and these are obviously not the correct options because of this very same reason. When you add up these two, so you won't be getting anywhere. Well, that is it for this video. Thank you for watching.